All right, we're going to graph a rational function here. We'll do a simple one for this one. So we got y equals, say, 2x minus 2 over x minus 3. All right. Now to do this, we're going to first find our vertical and horizontal asymptote. Our vertical asymptote, remember, is just simply saying the denominator equal to 0. So in this case, it would be x equals 3. You can ignore the top completely when you find the vertical asymptote. So we'll go over here to 3 and put a vertical asymptote. Now, asymptotes are not actually part of the graph, so we're going to make this dashed line. The horizontal asymptote depends on the top and the bottom. Okay, so if you'll notice here, the degree of the top is 1, the degree of the bottom is 1. Since they're the same, if you refer to your notes on horizontal asymptotes, the horizontal asymptote will be the ratio of leading coefficients. That would be 2 over 1. That makes my horizontal asymptote be y equals 2. And if you're not sure about that, you might want to refresh how to find a horizontal asymptote. Okay, so I'm going to go to 2, and I'm going to put that. So those asymptotes are going to be lines that our graph approaches more and more closely. And to know where it is, we really need a point in here. So I'm going to just pick the point 0 as an x coordinate. I'm going to put it into our function to get a y coordinate there. So if I put 0 on the top, 2 times 0 minus 2 would be negative 2. If I put 0 on the bottom, 0 minus 3 would be negative 3. So it'd be negative 2 over negative 3. Again, that's just putting 0. I'll show you real quick. Just putting 0 into both of those. If you do the math here, that's going to make 2/3. So 0 2/3 would be a point on my graph. So here's 0. 2/3 would be, you have to estimate. So it's going to be just a little bit above right there. I'm also going to go ahead and get this point over here at say 5 or so. Okay, so if I do the same thing with 5, change that to a 5, and change this to a 5. 2 times 5 is 10. 10 minus 2 is 8. 5 minus 3 is 2. 8 divided by 2 is 4. So it would become the point 5, which I put in, and 4, which I got out. And you may be, in some cases, you may be given these coordinates, but here we had to find them ourselves. Of course, you could use a calculator or graphing utility, but if you're going to do that, then why graph it by hand anyway if it does it for you? But 5, 4, 1, 2, 3, 4 would be here. Now, I'm only going to graph the 2 points just to show you the feature of these graphs. You could find other points to help make the graph more precise. What a graph is going to look like here, these end branches, sometimes there's more than 2 branches, but here there's only 2. They're going to get very, very close to the horizontal asymptote. It actually never touches it. It gets closer as you go farther left. Okay, we're going to hit our point there, which is right there. It's going to do the same thing to our vertical asymptote. It's going to get very close. It's like it's attracted to the asymptote, but it can't touch it. So it's just going to go down, again, get closer and closer as you get closer and closer to it, but never actually touch it. Put arrows on the end there. So this is a branch. And again, we could have been a little more precise if we had another point. Same thing is going to happen over here. You're going to get very, very close to that vertical asymptote, but you're not actually going to touch it. It looks like it coincides with it, but it never quite gets to it. Okay. The graph should never bend backwards and go away from it. It always goes towards it. And same thing here. It gets very, very close to it. And there are other things to talk about, such as domain and range. That we could talk about here. We could do one with more than one vertical asymptote. There's such thing as a slant asymptote. There's other things here, but just wanted this video to be a quick tutorial on how to graph a rational function with a horizontal and vertical asymptote by hand.